Okay, and this is question 1 from the proof game, and it's asking us to prove that segment YV, Y to V, is the same as segment W to V. That's what it's asking us to prove, and it's telling us we know some things first. The first thing we know is that V is the midpoint of XZ, and if that's the midpoint, then that means that means in red I'm going to mark what we know. We know that this piece is the same as that piece. Okay? We also know, and I'll put this in red as well, that XY is parallel to WZ. Okay, so those are things we know, and I'm going to write those down right away that we know. So we know that first thing is V is the midpoint. And that was given to us. So that's our first thing we know. We also know that WZ segment is parallel to XY because it was given to us in the problem. So there's our first two givens. Now they don't give us any sides or angles, but let's talk about what the goal might be here. Our goal is to figure out how to make the blue ones the same. And one of the ways to do that is to show that this triangle here would be the same as this triangle here. And we do have some information that will get us to there, and we'll have to look for some information, and we'll use one of our shortcuts. So let's do that right now. And the first thing I'm going to use is, whoops, I'm in the wrong one. When something's a midpoint, we know it cuts it in half. So we know that XV is congruent to ZV because it's a definition of a midpoint. You're saying, well, big deal, I knew that already. Well, we couldn't use it. We already wrote it in, but it tells us that we have a side. That gives us the first side. Okay? Now, the other thing that happens is since the lines are parallel, erase that and do it in black. Since the lines are parallel, we could treat this as a transversal. So I'm going to draw these in with the parallel lines, and that will help us see what's going on. And when we do that, we'll see that this angle and this angle have to be the same because they're alternate interior angles. And so that gives us as an A. And so I'm going to write that in a second here, but we're going to write that down. That angle, the first angle is angle W to Z to X is congruent to angle Y to X to Z because they're alternate interior angles. And that gives us an A. So we have this now and this the same. And so my question is, what we need to do is think about those triangles again. I'm going to color them in. Think about these two triangles. Okay? And I need one more piece of information. I need 3 pieces, and some of you are already seeing what it is, that this looks like it's the same as this. Okay? And those are vertical angles, so let's write that in. That gives us another A. Now, we just noticed that it was going on. We didn't actually have it telling us it. So it's a piece of information that just comes out on its own. So I'm going to put A here, and I'll change my writing, and I'm going to say the first angle W to V to Z is congruent to the angle Y to V to X. Whoops, I forgot to put the angle symbol in. Let me erase all that. And that's because they're vertical angles. So all these things we've learned are coming back to be used in the proof. And when we look at the situation, it looks like we have these angles touch a side, but this angle and this angle are across, so are touching the side as well. So we know that was by A angle side angle. So I'm going to write that this and this and this tell us that the triangles W, V, Z is congruent to triangle Y, V, X by ASA. And now that they're the same, we have the corresponding parts. And so we've got the corresponding parts, which is what we're trying to prove, that YV is congruent to WV by CPCTC. Corresponding parts of congruent triangles are congruent. And we finished that one.